in the gas. When you look at that, what you see from this is that the carbon dioxide can be a substantial source of carbon dioxide that's in a concentrated form. If you want to contrast from like direct carbon capture from the atmosphere, we have about 400 parts per million of CO2 in the atmosphere right now. This is parts per million of CO2. So definitely capturing a source, and it's a good way to use the CO2. So one of the things that you look at for designing a system, you look at the gas mixture itself. So you look at something called Henry law of solubility. It looks at the gas, how much CO2 is available for a wastewater treatment process, and the pH and so forth that you can accomplish by injecting a small side of a wastewater treatment plant, 15 million gallons, up to this in this example, 176. And with this, you can actually obtain a lot of CO2 from a ton standpoint. You're 8 tons in the yellow line there to up to let's see here, 45 tons, which again that's equivalent to a couple of wastewater trucks. So from a standpoint, what I wanted to show you here was that if you look at the bottom line here, that you can work with the amount of CO2 that's available and accomplish some of these pH adjustments. We changed the chlorine effectiveness by 25%. That's because chlorine takes a form. I have in yellow there, there's really a factor difference of about 100. So it's significant in terms of changing pH a little bit can mean a lot more disinfection. But by decreasing the pH in the range of, let's say, 8 down to 6, improved disinfection is significant. And this is the second. When we look at phosphorus removal, as the graph here shows on the right, that by changing pH of about 1, you can get 80%. This is just a conceptual example of how the process works in the marketplace. Whether you're familiar with Astera or CMP Aeropress, what this process though does is it uses the CO2 for better control over a range, which the other ones do not. In terms of solid air gas flotation, this is used extensively in wastewater and also food processing and digestion. And in food processing and digestion, it's used as a pre-treatment process, and it basically floats the air. When you use air, it floats this out, they're all flow to the top. This is going from about 1% solids to 5% solids. And then
looking for the word fluoride, and finally I saw it. This interesting example, but we had a problem. We bought new centrifuges, and old centrifuges, nothing happened, but new centrifuges, it happened before. But the pressure, the bends and so forth that are there, it caused the fluoride to be
very fascinating.
Other questions?
Pass-through system. It is possible to configure these in regeneration forms, but in general, you can keep the equipment a lot.
Many of the pollution contributing process, primary emission is carbon dioxide. Industry process, the primary pollution is contributed by is the primary pollution contributor, right, in the industries.
Actually reduce the
cost
time.
The cost factor, whatever plug-in technology
Yes.
into the process.
As that want to use CO2.
Thanks. With that, we'll have to close questioning and move on to our next speaker, who will now Chair of the Department of Materials Science and Engineering and employed at His interest is in nanotechnology and its application to environmental and economic problems globally. Professor.
These are not very easy events to arrange with multiple countries involved. The compliments we believe is happening in this area. The scale and the scope of the problem, as you know, with more large, is such a scale and scope that you have to have a solution that will have a tantalizing title: Recover Means Reuse and Repeat. In the last last few years, we're really bridging the gap between material science and environmental engineering. It's again our company's Coral Innovation next door, if you have any technology. And this is the legacy of pollution the last 2.5 centuries, loss of pollution, water, air. And now it's no longer considered pollution because it sort of shows my vintage also. And for those who have seen that, there's more, I just wish that. So we need to have solutions which are sustainable. And in this energy, it is, I think, a hard fact that you need to have non-renewable also to develop. So for the foreseeable, one way to sort of approach it is this more holistically, looking at all these, the stability of the environment that you need to balance. And now the emerging approach is the idea of sustainability, whereby can we have instead of a linear resource or feed back into the system with minimal waste. Key point here is that we could cut trees and we do all sorts of other things. We study it at the fundamental level, which we do at the universities, fluid and surfaces. And that understanding, we want to piggyback on systems which can be scalable to every year, 8 million almost. So imagine over the years that we repurpose it and make it into a technology that has to satisfy these, but it has to be eco-friendly. It should not create more problems than it solves, right? And second, it has to be ergonomic. This is a very incumbent problem, right, going on for hundreds of years. So we need solutions which are very easily deployed. You don't need to have complicated computers and so forth. And last but not least, something that I much more as part of the startup, it has to be economic, it has to be affordable, otherwise it will not be deployed. So one of my inspiration is SpongeBob, and there's a TED Talk if you're interested, there's an informal way of presenting this work based on the idea of teaching old sponges new tricks, old dog new tricks. And sponges are everywhere and typically waste product in many cases, and can be leveraged that by just imparting a coating. So all of us know that sponges have great affinity for fluid, so you can absorb. Very selective, it is a mixture that absorbs all. All we have done is created a nano. So we call this as the story of R, the letter R, because what we typically do is take a sponge system with a large amount. It's only a coating, it's like a paint on the wall. It's very tiny surface, and I'll show you one with water today. And you absorb that selectively, and I'll show you exactly the nutrients. And then the idea is, can we recover that? And so we want a post-it note effectively, properly of this resource, so that you can, paste it, remove it, paste it, remove it many times. So you want to recover in use. You can have, in the Midwest particularly, you've had a couple hundred years of smelting, so you have a lot of copper, zinc, and available. Usually when you get your December gift, you pull it goes into landfill. So all we do is repurpose that and put a coating by just dip coating approach. In such a way that you can see that it's a portland droplet, so it's very hydrophobic, so it does not absorb any. And as soon as you put a droplet of oil, it immediately absorbs. So in a mixture of oil and water, as you'll see shortly, this is aide oil and chloroform underneath, and you can see that the sponge studies that we have done. And just we were awarded the US patent for this composition of matter coating, which is based on polyurethane. So when we initially showed this, most people say, hey, but we were very surprised to learn from Coast Guard and many other collaborators that we have developed the last few years. There are almost 20,000 oil. So there's this sort of real opportunity, can we remove amounts from water to make it palpable? And the answer is yes. So we have developed a new product called media that we've demonstrated. So compared to the competing product that you see, which are rather expensive, and we use it and keep that going repeatedly. So you have absorption 25, and then you can reuse it 25, 30 times. So we are making a proposition that's 1,000 times better. The Coral has now got approval from EPA as well as the California agency, which are the most stringent rules, as you can imagine. And so we are we say, yeah, there are some other mechanisms, phosphate, non-renewable resource, tremendous. But using a coating based on iron, and so we call it a coral coating, and step one, and along with me, develop this. So the basic idea is you take a cellular, 25% of the coating provides you with this particular sponge. At low pH, it absorbs the phosphate.
your membrane as a cathode or anode, or if you are using an AC current. On the basis of that, there are some antibacterial properties. You can go electrocleaning. So mostly these membranes add additional chemicals. You can detect the fouling even before you have improved ion exchange or the contaminant removal. You can deal with the mineral scaling. And in general, in last 15 years, the majority of conductive elements was used for the conductive polymers. Some papers on metal-based surfaces, and majority nowadays, if you see last 5 or 10 years, the carbon nanotube and graphene has main elements what used to make these membranes. So why graphene is claimed? Professor Vinayak already has shown something, and mostly it's how well proved its environmental application. It can act as a very good antibacterial. It can act as a catalyst. We can use electrode for fault degradation and sensing. However, if you see all the method by that we generate graphene, it's multi-step process. And if you want to make membranes, then it's even more steps. So then there was in 2014 when Professor postdoc student Dr. Ling, he and then later they optimize it, and just by laser, CO2 laser, I have published this paper in Nature Communication in late 2014, and it has shown potential. You are not using any kind of chemical, you are 3D porous graphene surface. And that time I went to for my postdoc in Israel and membrane technology, and where we have demonstrated these laser graphene surfaces shown like these laser induced graphene surfaces without electricity, and with electricity they can kill the bacteria. So because of 3D texture, these textures inhibit the biofouling, and when you apply it because of the electrical effect, you are able to kill the bacteria. So with these surfaces has so excellent anti-fouling properties. So here you can see this is a biofilm, but on the laser-induced graphene you don't see anything. We have tried to understand with several chemical properties, but nano-sized fibers. So when we destroy those textures, and then if you see when we have done the biopsy, if you destroy the texture, they will not be able to resist. So the main reason for it of that also we have tried to see with the electricity what it's doing. With the electricity it's shown a very excellent result. It was able to kill the bacteria. We have shown several ways like you can get a complete disinfection by using these laser-induced graphene-based texture. So laser-induced graphene-based biofilm, and with electricity they can kill the bacteria. And with that, try to now it was a challenge how to transfer to the membranes, and with more modification and research, and the PISA lab from I was the lead author for this work, where we have surfaces, and these filters were very active. It was same. Their electrical properties was even better with the sulfur. So sulfur shows some additional capability. Came in ACS Nano, and we have demonstrated how a single step formation of these membrane can happen. We recently also demonstrated how crucial you play with them. And then we further came up with several, because when you are taking a membrane and you are destroying the pore structure, so then you need to further make some modification if you want to convert into the ultrafiltration or nanofiltration membrane. Still it's a win-win situation because we are getting our laser. We have demonstrated several ultrafiltration based membranes. However, if you do additional, as I have already told, if you make additional, you destroy the texture, you will see more biofilm formation, and that's what we have shown. If you have normal laser graphene, there is no biofilm, but if you do more coating on the surface, you can show the biofilm growth. So you need to optimize other things by using these membranes. Ciprofloxacin is negatively charged, kind of as a deuterionic, and then applied potential if your membrane is of years we have demonstrated several membranes where we have improved by making composite with different kind of oxide. We have shown with the titanium suboxide, the normal laser induced graphene membranes. So it's also like remove these viruses by using this kind of filters, and in single step how we can convert to be utilized for inactivating viruses, making a new generation evaporator, interfacial evaporator. Also how electro-cleaning of these laser-induced graphene without any chemicals can be done, and also we can do process which can give a very treatment for very high base surfaces. Patents in last couple of years, and our main aim is to how solution for the water purification. So just like to thank my PhD students and the collaborators, and also WWI for giving me this thing. And this most of the work is 4 or 5 students. And just the announcement, we have got a new Center of Excellence on translation.
My question is a little philosophical. In my 69 years of experience in this field, the invention of activators started in 1914. And even seeing today the water reclamation plants and plants like that around the world, by the membrane technology. And coming from India myself, and the aide lab here, what is your future direction or expectation for application of these membrane type of technologies in treating our wastewater cities?
I think the one thing is, like, if you see there are some gold standard based on membranes now, like MBR. MBR is kind of, MBR is also going to come because you cannot deal with several problems with the traditional system. Ultimately, as per the engineering, all 4 plants going to come on MBR. MBR based system, they are going to be a kind of a gold standard. For desalination, RO is already well accepted. So that's what I see. These things, yes, these are kind of evolving electrical conductive base. If you see making modules, they have challenges. How it will be able to go in that direction, we are still working on. Maybe they will not probably going to be a directly used for these contaminant removal, but we have found a way like in an ED mode. So we are working on that, and there are several other from it, and ultimately it also will go for that, because if you see, we are getting a nanofiltration level of rejection with ultrafiltration. One module design, because you cannot go with a module with this, because making the module. So it will take time, but it will come. If you take membrane-based technology, they are already there in India. The slow adaptation is slow, but it will come, because removing the emerging contaminants and having a constant good performance, all many times. So if you want to have a better system, you need to move towards this some advanced technology.
Are they operating and maintaining the systems nicely?
So see, MBR-based system, there are very few what I found in India. So new plant is under construction, but there are some hotels and some small places they have MBR-based system. So or some other European country, they are running MBR system very nicely, they are getting very good result. So in China, now they converted to MBR, and it's very good for both municipal as well as for industrial industry.
We work with also membrane systems.
So see, like, these technologies can be applied, but obviously unless until we have a very perfect module design, because household units can membranes can go longer. If the companies are forcing you see the lab still they were in good condition. So if you want to use it for that long, we need to go and take this which we are trying. We have got several startups in IT Bombay, they are taking this technology. Can we use, but obviously without proper testing, I cannot make it. But it's
we're standing between us and the networking break, and otherwise we've got about 10 minutes before our flight. Invite speakers. And stay. Plug. This is for all. Thank you very much. This is for Dr. Ravi. Thank you very much. Not off yet.
Okay, thank you. Okay. Smile. Thank you.
Thank you very much.
So before I begin, as favor the guy by the entrance. Could you be good? So my name is Juan Velasquez. One was water management to make sure your vision, and we're gonna have 5 minutes for questions. Our first speaker. Well, this presentation will be held by 2 speakers. Mr. Shah. They're gonna be talking about. So Dr. Mohammed, please, you can come up. The floor is yours.
Good morning to everybody. I'm going to tell a story about transforming a rural hamlet into a thriving urban economy, plus transformed a completely rural area into a knowledge hub, which is currently getting benefiting, except this is what the city now is. I don't even compare with the city of Chicago in India. Our project has completed in record time and economically challenged people of state area. Total revenue and plus we are aiming to produce so far we are providing, as you see in the previous slide, almost funds none other than spent even through best roads. Till today we are getting almost 5,000 years ago. They had better practice to recover the precious water. Countries now. So they had much better practices and they're not here. They're talking about 5,000 and generators was not there, electricity was not there. They harnessed and we contributing a lot of carbon to the atmosphere. They were clean. See the structure you see over here? This is called the, attraction or passing the air through natural process. And this is the water tank, what you see over here, is doing two purposes. Maintaining the water quality, oxidation is improving, as well as it is cooling the water inside the tank. And they have very effective waste disposal plant systems. That yellow mark, by using the natural, sustainability has to be inculcated from young minds. So if it's locally made and kept in the reception itself, because we need plus using natural resources, increasing job for the people around. So gravity we have extensively used. So this is what my record. One side we have a dam, we created the support of water, created the concrete tanks. And there are 12 absence of bacteria, like E. coli. We will give to 180 liters per day per person. Value of person gets. This is the pond, this is the well. Of water that I was talking about, this is the current. The current in this slide shows we have two challenges, and here to discharge back to the existing groundwater level, but we have to the existing groundwater level, but we don't want to do that. We have did a benchmark, and we have presented this paper in the UN 55%, and our air quality, even after infraction, is best in the world. In action, is best in the world. In our cities, like Delhi and Mumbai, is almost 10 days of this. Delhi and Mumbai is almost 10 days of this. Doing such ability, and we created assembled a drone and kept IoT in the history. By integrating this and as a testament to this philosophy, demonstrated 65% people live in the rural area. In my to tell the honorable audience what we did using how precise
Presentation.
Now, started from Harappan architecture, which is very, very ancient architecture, how city now, but then how can you make it good? And that's the responsibility which, as a technology company, we had, and we took it as a any of the assistants or the kind of answers they have already built in. So the task, the way in which we approach the whole project was that it's of the highest quality. Then how do you sustain and solutions to make sure that city can sustain as long as possible? Maybe recycle quality, you don't lose it. Currently at the moment, traditionally what people do, you take a one time, you go test it. Yeah? So the amount of time to test the water after 3 months, it's not a rocket science. So what it does is that imagine a situation, you have an environmental engineer to the person will happen. So that's an AI, it's an artificial, that's what it is. A skill for self-healing, healing the top of it, it has got lots of data. The past data, that's what the experience now. When these three come together, that's where you get the best technology solution possible. So that, and then with AI model trigger a report saying, okay, there is so much range. How you manage the process is completely automated. You know what's the kind of you can instantly you get the call of the treated water. 24/7, it's being monitored. Imagine you have so cutting short. So high level technology architecture. If anyone of you are interested, this is what AI solutions which actually does majority of the AI's work.
Thank you, Mr. Chair. Wonderful presentation. So, since we reach all, no questions? All right. So, thank you, Dr. Mohammed. Thank you, Mr. Sharif. Okay, now it's my pleasure to introduce our second speaker for this session. He is a PhD student in Kartik. He's a student in the Department of Agricultural and Biological Engineering at Purdue University. His research focuses on biological approaches for treatment of agro-industrial wastewater and resource recovery from wastewater. Kartik has a master from Bangalore. Please, you can come up. All right, the floor is yours.
I know all of the issues that we have with wastewater treatment and water. Problems. So I'm very appreciative of that. So today I'll be talking consumption. We will look at some nutrient reduction and some microbial insight. The hypothesis and objective was the methodology and some results that we have obtained throughout the So eggs, egg wash wastewater is what the agro-industrial wastewater that I'm talking about. So eggs are consumed by all age groups in the United States and in the global food system. And USA is the second largest producer of eggs in the world, and them along with Canada combine for 8.3% of global egg production, whereas Asia as a continent contributes 62 to 63% of the global egg production. This washing process involves some water and detergents, and this produces high hope and other countries have on how these eggs can be stored without any degradation in the quality. So onto the oil and then refrigeration. And third one is unwashed eggs but refrigeration. And third one is unwashed eggs but refrigerated, and finally unwashed but with the eggs that are produced. Once these eggs are produced, they are collected in process. So this releases some protein open waste. So this releases some protein open base stabilization bonds, which could also alter base stabilization bonds at full day, can either also alter base stabilization bonds at full day, can either the first one is anaerobic digestion, second one is aerobic treatment of activated sludge treatment digestion, second one is aerobic treatment of activated sludge treatment, and what could happen if aerobic treatment of activated sludge treatment, and what could happen if the field application continues, and what could happen if the field application continues, such as the field application continues, such as egg crossing industries. The sludge that is formed during electrocoagulation. The sludge that is formed during electrocoagulation will also These approaches, however, have never been tried in ponds. Ponds, followed by possible anaerobic digestion or due to its nature based on the different industries of a project. So for this, my objective was to look at a small scale batch mode biological treatment, egg washing wastewater into the bottle. Like the bottle capacity is 250 ml. We add 200 ml of 21 days with sampling ml. We add 200 ml of 21 days with sampling every 7 days. Milk properties were measured by the spectrophotometric methods. Mentioned the of COD, the control which is just egg washing wastewater with its bacteria is able to treat it, and the treatments that we have applied, but there was a when we added analysis into the study, we identified a single variant which is where our chemical analysis was also performed, and we observed a shift in the community from day 7 to day 14. This value corresponded to the sudden degradation of chemical oxygen level at day 7 and day 14 respectively. Is actually playing a role in the removal of different nutrients. This also changes in the removal of different nutrients. This also changes in the bacteria based on different treatments employed. Nutrient concentrations, and algae is not observation of this specific bacteria. Was or is necessary to identify how
Any questions for our speaker?
Yes. And algae generally does not grow at lower temperatures, so we do not think of doing them at low temperature. The community changed over time. And also, egg washing wastewater is the upper layer. There is an upper layer formed which reduces the amount of oxygen samples every day. So this could have condition to an anaerobic condition, which could lead to a shift in time from varying from 2 to 8 days. But I just don't have the results here. But our goal initially was to just recover the phosphate in later stages. So I'll have to look into why it was a bad thing, but if we were interested in using the wastewater in an anaerobic digester, then that would be a bad thing to change.
Agricultural and Biological Engineering at Purdue University with research focus on the integrated of nutrient removal. Norway, would you please come up to this?
Today I'll be presenting on our research work. So So the global demand for aquaculture is rising rapidly as populations grow and so here's the problem. Fresh fish meal is supply and competition. Second, it's not sustainable. Third, wild fish is unsustainable and heavily dependent on fish meal. So that will depend on fish meal. So that will also get an option that can be reared on organic waste. These allies organic waste that can be reared on organic waste. These allies organic waste into nutrient-rich biomass. They grow quick protein source for aquaculture feed. They grow quick protein source for aquaculture feed, both environmentally and economically. This slash is new and economically. This slash is nutrient-rich and abundantly available with ammunition and generate a valuable protein product. Slash treatment efficiency. So here's the chemical treatment. We find the slash upper portion. Resource recovery of contaminated environment. So the electrochemical setup. Here we optimize the chemical setup. Here we optimize the pH, current density, and after this method we found the resource current density, and after this method we found the resource like density, and after this method we found the resource like the treated clean water. Electrochemical process helped us to optimize treated clean water. Electrochemical process helped us to optimize this balance. Treated clean water. Electrochemical process helped us to optimize this balance. So this slash had significantly better growth at low cost. So this slash had significantly better growth at low cost compared. So this slash had significantly better growth at low cost compared to the control. In the percentage of larvae that reached the critical. So this stage mainly when larvae stop feeding and start feeding. This stage mainly when larvae stop feeding and start feeded slash diets resulted in that not only did they grow well, slash diets resulted in that not only did they grow well, they also absorb waste by turning waste into high value. They also absorb waste by turning waste into high value aperture. They also absorb waste by turning waste into high value aperture and waste management sectors. So thank you. It's just new. We're trying to utilize black soldier fly. It's just new. We're trying to utilize black soldier fly larvae to assist. So if you have any suggestions,
Now we have time for questions. Now can the speakers come up to the stage, please?
Hello? Yes. Kartik, thank you very much for your presentation. Just a second. Just a second, don't take pictures. Okay, we can.
Come on.
From the since first conference onwards, Kaja, please come. Credit to Mr. Sam and Mr. Kaza.
Let's give the big approach to them.
Is that printed here? Camera low? Can you come in the other room, on the stage? I got a question on slideshows. All right, it's fine now. I could have now it's good. So thank you.
Hello, thank you. Good afternoon. We are all ready for the victory function, which is with a high-powered panel discussion with a moderator, another than FFK, and you can see all the panel members here already seated here, getting ready to share their knowledge on this particular subject. The 2 days of conference, international conference on resource recovery. Hope it went through very well. Because like I'm standing this side, so you are the ones like we are like enjoying this conference, so participating. You heard how did it go? Good.
big effort. People have a lot of confidence. People have energy conference, solid waste conference, everything like it. It's a very specialized one. What we have done is because the requirement of the at the village levels and rural levels, the other part of the world is like everything little bit each but together. So that's why we have at the resource recovery side, we have got this big triangle. So I will just take a couple of minutes and hand over the mic back to the cliff, so we not come in between. So yesterday and today we have got a lot of work went into. This is our 7th conference. In fact, like 6 conferences we did outside, 4 in India, 1 in Bangkok, 1 virtually, and finally we landed back at our home turf and hope we did a home run. And it is also like my privilege and honor to recognize our conference co-sponsors, mainly the Illinois Association of Wastewater Agencies, Membrane Society, Indian Membrane Society, Purdue University, the Illinois Water Environment Association, NRC, IPCC, of course, University of Illinois, Chicago is the co-conference partner, and Chicago Department of Water Management, and Illinois Chamber of Commerce, Zero Waste, SHPE, then TCF. And then the host of the business sponsors, they came and helped us to get this conference going. So today I will be the master of ceremonies for the evening ceremony. Now you can see that like just one triangle here, we've got like energy at the top, water and wastewater, solid waste, all interconnected. As a water and wastewater guys, we consume energy, we also produce energy. And same as the solid waste, anything processing solid waste, they consume energy, they produce energy. Probably we produce more than what we consume. Then the energy guy will supply to the people of the industry. So we are talking about when yesterday Chris told that I visited the golden triangle in India, and he made this water be it's a golden triangle right here. So that made me ask Chris to come out here. Now I asked Mr. Chris, he's the director of the Energy Center of the University of Illinois Chicago, and the co-chair of the conference, and also the panel moderator for today. I request to introduce their panel members and go ahead with their panel discussion. Thank you.
Thank you, Sam. Okay, here we go. So, good afternoon, and welcome to today's panel on planning for a sustainable future, aligning community infrastructure with energy environmental strategies. As we're we're getting to the end of this conference and pulling everything together from the energy side to water and wastewater to solid waste management. It's that would be nice to have the growing pressure of climate change, aging infrastructure, and evolving community needs. This conversation for how integrated planning across water, energy, and waste systems can drive sustainable development, resilience, and innovation at the community level. So I'm honored here to be with my esteemed panelists here, a number of leaders here who work spans of public utilities, engineering, global infrastructure, and advanced environmental technologies, each offering unique insights into how we build a more sustainable, connected future. So I'm going to do a one-sentence introduction to all of you, and then I'm going to eventually turn it over to you all. So I'll start here from, you're right. Yeah. Well, right back, whatever. This is right here next to me. So Martin Jacobson is a senior engineer for strategic energy management. Management's been a long 2 days. But a good days. At ComEd, driving energy efficiency by Dr. Catherine O'Connor, serves as Director of Engineering at the Metropolitan Water, Sharon Waller, who is Commissioner at the Metropolitan Water Reclamation District of Greater Chicago, where she champions sustainable water and infrastructure solutions. Next, we have Paul Baker, who represents Gillis, contributing engineering expertise in environmental technologies and sustainable infrastructure systems. And last but not least, we have Dr. Uday Kalkar, who is the CEO of NJS Engineers India, bringing global expertise in integrated water and environmental infrastructure planning and implementation. So please give another round of applause for our So as we look at the sustainable future, what will this look like? I was in the energy track the entire time, but there were challenges that were brought up, maybe some scary challenges. How are we going to meet the growing energy demand? And I'm sure there are issues and challenges and demands on the water wastewater side, but also the solid waste management side. But there's also opportunities for innovation and bringing solutions to the table. So I'd like each panelist to go, if we don't mind, from Marty on, to give 1 or 2 minutes of your organization and what your organization and you are doing to impact energy and environmental strategies and community infrastructure. So, Marty.
Well, thank you, Cliff. Thanks for having me. Always a trusted partner with all of our customers. We serve about 4 million customers throughout the Northern Illinois region, if you don't know. And we are big on sustainability. We're always trying to get energy efficiency, solar, wind, and make that process good for everyone. And working on the dependability of our entire system with all the climate change, more destruction, things happening with the efficient system, and a little bit more reliable for everyone. And we're also trying to bring our costs down and be a good cost provider for our energy and be a trusted source for you for energy efficiency and also for distribution and all your interconnection needs.
Great, thank you, Marty. Catherine?
Good afternoon. Catherine O'Connor, Water Reclamation District of Greater Chicago. There was a presentation yesterday. One of my colleagues talked about our stormwater management program. We are the wastewater and stormwater utility for essentially Cook County, Illinois. We have been granted the status of being the utility of the future under our terrific leadership, where we recover resources, we recover phosphorus, a phosphorus-rich fertilizer. We have roughly a $50 million electricity bill, which Chicago has been working with us on energy efficiency, which we mentioned here, variable speed drives, and anything we can do for energy efficiency. We're very motivated there, and we see an awful lot. We have a lot to talk about on our sustainability initiatives. Thank you.
Great. Thank you, Catherine. Commissioner Waller.
My name is Sharon Waller. I am an elected commissioner of MWRD. All opinions are my own and not necessarily those of the district. Legal makes me say that. So I'm proof that staff and commissioners, elected commissioners, can work together. So I'm very happy to be here with Dr. O'Connor. What led me to run? I'm a 30-year water engineer with a PhD in water quality, 30 years of experience mostly on the drinking water side. In 2016, I was working for the state of California on a research project to determine if direct potable reuse was feasible. Yes is the answer after 33 projects. I was just one of those projects. But that gave me the language to look at our codes here in Illinois, and I was shocked to learn that we discourage irrigation reuse, and we basically make it illegal to reuse water in any other manner. We in Illinois basically regulate our wastewater based on history of last use instead of quality. So that would be right.
Great, thank you. Commissioner Paul, from the engineering perspective.
My name is Paul Baker, and I represent Guild Associates. We're out of Dublin, Ohio, and we are a manufacturer of biogas cleanup equipment. So we manufacture the equipment that will take biogas generated from a wastewater treatment plant anaerobic digester and upgrade it so it can be put in the pipeline as RNG. We feature systems that will go as needed at approximately 10 wastewater treatment plants across the United States. And
I've been working in India for the last about 20 odd years, spent 15 years here in the US. gone live next month. So it is a sustainability. We need to look and increase the energy through various combinations thereof, using natural gas and anything else that is possible. And another second one project that we're starting to do is why not to use wastewater that is highly treated for generation of green hydrogen for sustainability. Because every kg of hydrogen or every kg of green hydrogen generated, you need 20 kgs of fresh water. So if you save that 20 kg of wastewater,
Great, thank you. So you can see we have a panel. There's variety here. We have the United States, we have India, we have representation of small electric utility, we have technology and engineers. So as we give all these remarks and comments, think about the broad spectrum of facilities. Okay, panelists, and whoever wants to go first, I guess we can talk about who wants to go first, but ask to chime in on every question, but let's look at our first question. How are long-term infrastructure plans evolving to address both energy? Be the first race over. How are long-term infrastructure plans evolving?
to answer your question, this is a joint program between consultants, clients, and small examples. Suddenly you get a rain with high intensity and very short duration, and we get flooded. So if you want to make that sustainably, obviously government needs to find funds, because that's been critical of them many times. Solution. We don't want to put a high tag to it. We want to make sure that it's the cost. It has to be a partnership. You can't do it alone.
Anybody want to talk more about that, how that's evolved?
Our Board of Commissioners, Water Reclamation District passed the tunnel control plan for both stormwater management and to protect our waterway. So it's a pollution control effort and flood resilience. Terrible, terrible storms, and that's part of our presentation we'll be giving later, where people are flooding, much less our reservoirs filling. So the intent, we are kind of backing in, and we're forced to deal with climate change, and we need information on how to protect structures from flooding. So that's my answer to that. How do we alleviate flooding? The flooding. So we deal with droughts, and then rain events. It's all correlated.
Go ahead, Commissioner.
From this work, I learned that loss of energy mitigation is key kind of pivotal things. Once you take away the energy, you're basically not treating water anymore. But then also the risk associated. Then additionally, we really need to identify alternatives. The most common, the obvious thing that we're just not looking at is our wastewater, which is highly treated. So we have new 10-state standards, which apply to all of the great states. And the new dated 2022, so that needs to change because it's basically eliminating half of the water that we access water from. It increases in extreme weather flooding. So these two things that can be addressed with the same technology.
More proactive now moving forward than maybe we were more reactive in the past. Are you seeing it, or do we have to get there?
I think we just need a complete reimagination because our 1972 and we're acting. So I think we just need to take a look at all of our code, look at it through the eyes of our children instead of just making small changes.
We're seeing that the challenges are barriers when trying to align energy, water, environmental goals within infrastructure to making things happen.
Well, in the Our dry weather flows are down. So that's a big positive here in California and even New York City for other reasons. We haven't had it 1 million gallons per day. Now they're just over 200 million gallons per day, and dry weather flow is about here. They could nod or shake their head that I'm incorrect. So this, and water main replacement with the city of Chicago, all leaky water mains, you said 40%. Now we have the benefit of much stronger, higher strength waste that we're treating, so our process is levels. But not enough, as Steve McCracken is dealing with the Sierra Club. The environmental cost of, we should limit, that's what opinion.
Sure. Thank you. As far as utilization of biogas from the digesters, it's really not well known in the community how valuable that gas is, and it typically $30 to $50 per MMBTU, when the actual equivalent molecules of conventional natural gas are only worth $2.50. So to develop that into a RNG system or into a CHP system or anything like that can be a revenue source that can be, one, a source of pride within the community, because you'll have a lot of people wanting to come and see the facility and see what you're doing in that. And that can bring an esprit de corps that doesn't exist with your typical. What comes from that is one of the major we have with, not necessarily us, we just provide equipment, but our customers put the entire system together. One of the major issues they have is actually dealing with the gas companies to accept the gas. They have a hard time believing that they're getting more pure than what they're getting from their natural gas suppliers on the pipeline.
We talked about our administrative code, but it also business barriers as well. So the small utilities where water and wastewater district are going to be better able to make changes towards recycling water, both for industry, so data centers are coming, but then also irrigation and eventually reuse. And where water and wastewater are in separate financial districts, as in the city of Chicago and the county of Cook, they compete, and this is not helpful. So to share this finance and think about the broad need for change versus, not versus, but both and keeping our budgets whole to maintain the infrastructure and not, hopefully not, but yeah, that's because we like the people that not going to happen. We can't raise the budget.
Announcing the budgets, Mariana, education-wise, when your teams go into as the electric utility or promoting energy efficiency programs, strategic energy management, do you see these wastewater treatment plant utilities fully educated, or do they need a lot more education? Is your team able to help with their goals and their sustainability goals, energy related?
That's a good question, and really a lot of differences. Most are educated about their plans. We're going down to the team members, right? Everybody working on it. So the same thing, and understanding why they're doing the process, which is really kind of key, right? So instead of just one person understanding the whole process, especially when you're in a smaller plant, how does it affect everybody else, right? And how does it affect? So we're doing an awful lot of education with wastewater and with the team just to bring it together, bring their teams together. So MWRD is a great example of doing that and bringing multiple plants together to learn about energy efficiency together and some of the processes and how they can wastewater plants, whether it's water plants, industrial processes, right? So I was going to say, to getting the dollars and getting funded link them to all the other projects that are going on, especially with energy efficiency supporting a lot of that.
Great. Now pivoting, we talked about barriers, challenges.
Is okay, so Chicago is a very old combined sewer system. So, but New York is an old city with a combined sewer system that's made great strides. They have the benefit of having water and wastewater in the same financial district, or same financial center, so they don't compete. But when faced with a consent decree to reduce their combined sewer overflows, they created an award-winning grant program to incentivize water conservation and reuse. And that has led to awesome projects, including the Brooklyn waterfront, Domino Sugar redevelopment, where after a big rain, and now that 11 acres, 5 buildings is served by a 4 distributed treatment system that serves all of those buildings, 3 of the 5 buildings, with non-potable water, and that is an ROI, return on investment, of 14 years, because New York, City of New York is reduced cost. So that would be flat out heresy to suggest such a thing would happen in Chicago right now, but just because I can name it, I have.
All you when to go next.
Yeah, you mentioned alternative funding, running the equipment, and then selling the credits on the open market. There are also other ways available. And since you mentioned New York, I just want to, while it was a very frustrating project to get through, but beyond that, it is running well, and so this is something that can work in the midst of.
We're working with the Illinois Department of Transportation, the Cook County Forest Preserve District. The Chicago, we spend stormwater, we get 50 cents from another agency.
If you don't mind sharing something you shared in our energy about the landfills. What landfills are facing a challenge, but it could be an opportunity for another sector, right?
Yes. So the topic of my discussion this morning was organic segregation from landfills. So there is a little bit, there's 7 states right now that have legislation out there passed where they want to divert organics from landfills. And the whole purpose of this is landfills are very difficult to, nobody wants to build a new one. And so in order to extend the life of the existing ones, if they can divert organics from there, they will have a longer lifetime. They're not telling you what you have to do or what you can do with these diverted organics. What I'm suggesting is one option, specifically with food waste, is it can be co-digested with the wastewater treatment plant, and that has some very unique opportunities for creating more biogas and also creating a new revenue stream where you can get tipping fees. And on top of that, since these are mandates that are coming from the states, there probably will be either grants available from the standpoint of demonstration projects, or flat out, you're going to be solving a problem or part of the solution for a problem. And so I think there's going to be more advanced or more avenues for you to obtain funds for these things.
Thank you.
I think on the other side, the sustainability really comes into picture when you're pressed against the wall. Take an example of electricity not having enough generation capacity, so you go into solar panels. State of Rajasthan, which is the western side, most of it is desert, but they have put in a large amount of solar panels. So does some of the treatment processes in Chennai, which is south side. Water, but no water also, because it rains heavily and drains the wastewater, recycle and reuse, putting the water back into the reservoir and then using it from the other side. So what just told about that FOG, food and other things, have been pushed in India. Typically the FOGs are lesser percentage as compared to the Western world. It's about 35, almost 60% of electricity back into the plan, in that particular aspect of it. So I think a lot of things happening, people are looking very strongly, but again, if you really have advantage in doing that, why would people come and use that if you don't give them an incentive? So initially give them an incentive to the process. So I think that's happening in the last 10 years or so. It's moving into that direction very strongly.
Great point on incentives. Okay, I'm going to ask a question, and I'm going to turn over to the audience if any of you have questions for our panelists here. Think about sustainability. These new strategies. I'm interested if there's any comments on this one. So, given the pace of as well, the policy, regulatory, and funding changes, especially at the federal and state levels, how can wastewater agencies and firms stay agile?
Yeah, operational, so you don't have those capital projects. Sometimes that can offset the capital project process. So, and then getting the incentives is a big part of that. So,
currently experiencing a couple of funding snags for reuse, utility in the future. We want to maximize return to the economy. On nutrient-rich fertilizer. We want nutrient management, carbon management, and the most energy efficient. The money goes back in, we pay it back. That's a very reasonable financing. We have to.
Revolving fund is three goals that I set out. One is to repeal the prohibition. There are ways to get that done. For a chemical, amazing, right? So it can happen faster than you think it can if you can name it and boil it down to 2 sentences. It would be great if we could prepare for them. So most notably data centers. If we were, at least for the next years, rely on federal funding. But if we grow our local.
Paul or Dr. Felker, navigating through policies, regulatory, what are you seeing now in the plans with maybe ups and downs on policies? Maybe you two are probably going into these plans and talking about it.
From a standpoint of the EPA and the renewable, I don't think Congress has that anywhere in their top 15 things that they want to deal with right now. So I think
that's where they come from, and that's very important to get them. Once they get educated and issues, particularly in India, because I speak like I'm an Indian, but I'm American regional sustainability records saying that we will do this, and the new government or the Modi government in the last 15 years has really pushed into that direction. A classical example is our PPP model, where the concessionaire comes in, operates it for the next 15 years, only 40% it gets upfront in 3 years, and then the next 15 years gets the 60% gets enough understands it's happening.
Yeah, it seems like a lot of these plans need to stay focused on their goals. They're trying to do that to try and navigate through those. Are there any questions from the audience that folks might have regarding?
What about internationally and water management?
So trying to learn from other countries?
Yes.
That is what I had. Some of our colleagues just got back from Denmark, and they claim the process much more efficient. So we are internationally. Chicago is very water proud, and we were the first secondary wastewater treatment plant. And there are great benchmarks. I think we're
here in Cook County have economies of scale, and there's a balance now as we move into the need for higher treatment to access that economy of scale. Our federal government, right, which we're kind of thankful for in some ways right now. And this is why we come together in conferences like this to practices and where we can be frank with each other about our challenges and
Hi,
Sharon, you talked about departments, MWRD, maybe the Department of Water. Isn't it incumbent upon you, the elected official?
For different jurisdictions. Every single time I see MWRD and Chicago Department, see you presenting together. When can we see more of that? And it just gets a smile, but I am kind of a push and charm kind of girl. I'm not going to deliberately try to offend people because I just don't think that that's the way to go. So Ruth Bader Ginsburg said, fight for what you. So how do we get all of our, but you also have to keep in mind that these are different jurisdictions with different.
You're saying, you know, you use scale, I don't think you didn't use a Titanic, you use something else, but it's slower moving. Actionable things to do today. We gotta do it faster as a public. More responsive and thank you.
There's some questions over here. University of Chicago. Speaking about New York again, and waste from landfills, partnering with wastewater treatment department, so and diverting organic waste to waste treatment.
However, our Calumet plant does have excess digester, does accept fast oil and grease, and they do generate excess electricity. So that certainly is the future.
With reference to India, especially, the river Ganges is one of the most polluted rivers. So is there any...
Not looking at rivers as its entire area, including the river basins. They are covering almost entire river within the 6 states. Which are the areas that are more? Near Kanpur, where it's all most of the tanneries that are being turned out. There is a nala called dolphins. You can see possibly dolphins. You can get turtles back in there. We need to keep in mind that any river cleaning or any sustainability doesn't happen with a snap of a finger. It's working and it will continue to work. I believe the international community and UN awarded the government of India several others. So it's happening from 24 onwards.
Other questions up front here, Dr. Todd? You got a microphone coming up too.
Nobody. But I did. You watched it? Both SDG 6 and SDG 7. They really call it balance. Now, my question to you is, water reclamation produced 1939 in India. Whole of Dala was covered by. So what kind of synthesis we're going to make it to produce a lot of Indians? Because the sustainable development goes probably with the money and power that USA has and developing countries have. What you can do?
I think, Tata, I can answer your question. An American is still saying this proudly that India is now the 4th largest economy. So it will next to research. I mean, digester research has been going on for so many years, including research at Stanford and Cornell and other places, but never strong in energy here. We have a lot of energy available. We have a lot of water available. For example, when I was in Michigan, when I talked about
I think it's a little dangerous to think that anybody is a know-it-all. We are here at conference to learn, and there's a study that's highlighted in the Brave Blue World documentary.
Board and planning with a sustainable future. Let's start down with Dr. Calver, and then we'll.
I think we just need to continue this process. We can't stop. We have to do it, whether there's funding available or not. We need to find new resources, keep on going. There will be obstacles, for sure, but we need to see how we.
I guess I would advocate for speed, and I would say, and so don't always strive for a perfect solution, because there is no such thing as a solution.
So I totally think differently. Not that you, but just like I'm a different kind of thing. So
that's why we have a panel up here.
Right. Then you can make better long-term solutions. For instance, so that additional infrastructure with all the heartache of land acquisition and eminent domain is now not even in service long enough to repay for that asset. So we need to acknowledge that it's the water cycle and all water.
I learned so much here on zero waste and how to make the manufacturers hard to say. If you own a home, whether it's here or wherever you live, please disconnect your downspouts and plan all your roof flow to some green stays, dig a rain. We have a self-help on our website, the Green Neighbor Guide. That's a big step forward for stormwater management.
Yes, something that caught my attention was just partnerships throughout everything, whether it's there's, you know, who you partner with.
I request.
You want to stand up?
No, what's it? Where's the second? Okay, ready?
Please come onto the stage. We'll take a picture with the committee. Fast.
Oh, please. Make it cut. It should be in the newsletter. Yes. Fast. Okay, you guys want to? Yeah. It gives more authentic. Yeah, sure. Thank you so much.
Like this is Frank. I went to the first time in India with and we spent a week at our laughter yoga place. Session with one laughter session here. Okay, so and it's going to be about our hands.
Okay, we're going to Chamber of Commerce. Who leads the state's foremost business advocacy. 30 years of global experience. He has held leadership roles in Fortune 500 companies, on the Economic Club of Chicago, and is a best-selling author. If Luke, if you can join us on the stage up here.
Well, it's a pleasure and an honor to be here today, and you know, it's interesting that this conference is about water to be able to create energy. So it's sort of a cyclical type of situation, and that kind of sets the table for where we're going in today's discussion. So what fiscal year 25 looks like, and then what our growth strategy is overall. Really, base looks like the who's who of the Fortune 500. But I pause that statement to say that it's really only the 35% of our members that are these big logos. The other 65% are state all the way to the northernmost border, to our western border, and our eastern border. And really, it's a state that's full of a lot of opportunity. It has required energy and water to thrive. As we get into where the state is going, it's a tech-forward type future. You've probably all heard about 10 miles just southeast of here. Actually, in my old childhood, a block away from the U.S. Dale property in South Chicago, my childhood home is still there. And to tell you that it's a that time forgot, labor, the union and the battles between the unions and 18,000 jobs evaporated. And the South Side has struggled to recover since then. It is shows you the importance of what happens to every there's an effect. And this is what we echo down in Springfield. I don't believe that legislators have isn't always a robust conversation that's had are heard in the conversation. And energy is exactly where we're at right now. So neighborhood. We also have this thing called artificial intelligence. Who's heard of that in the room? That's changing how we're in that area. We had 4 substations that powered the entire neighborhood. That power consumption could announce that for the first time, you're going to measure impacts in electrical bills, not only from coming other parts of the state. And that is because we've taken this, I'm from the innovation circle, so as you heard from my intro, I'm from this side of things. So, that couldn't be further from the truth that when you're trying to do tech on a larger scale with something like the state of Illinois. Said that the state of Illinois is probably the closest thing to oil with regards to natural gas. We have somewhere in the area of 286 coal industry that's south of here. It's my personal belief that we have thought too much about the future without a path to get there. And that path of sustain, and otherwise you're going to see what other states are seeing, and I think are on the precipice of that. You hear stories in California of electric bills $17 a month and $2,800 a month. Why? Because there's been forethought to the supply side of the energy equation. You have to supply power to distribute, and if you have more drawing out of your supply, is impacted. And that's where Illinois is right now. But I say all of that because I look at it as an opportunity, within the state. One, to create an employer-employee balance. Wherever I go, because I've seen it in my own neighborhood, and I see it in places like Quincy, Illinois, I see it in places like Cairo, I see it in central Illinois. Everybody says, oh, let the big guys pay. You see those big logos, let the big guys play. But what happens when those big guys leave? They always have options, right? In a particular community, the suppliers that are the medium-sized small supply to those industries hurt. When they hurt and they downsize, they basically, the mom and pop shops, the coffee shops, the child care centers, people pull their kids out because they lose their jobs. And then nobody goes to the coffee hurt. So when companies hurt, employees hurt, communities hurt. The current economic state. Now we have to leverage that appropriately with a focus on the future, but there needs to be that balance. And currently I don't believe that there is that in Illinois. Second, we have to change the energy narrative. We have to develop that transition. That transition plan requires inputs that are natural gas that play to our strengths. That has been a strength for Illinois, that require natural gas inputs, and perhaps coal is an input. With the transition going cold turkey today, no natural gas, and we want a grid of solar and wind, which doesn't give you the capacity that you need. Okay? Third, we need to create solutions that are balanced for property taxes. I mean, for those of you that might be renters in the room, those of you and they say, oh, my rent just went up $400 this year. My landlord raised my rent. That is because his property taxes went up. If you're living in Pilsen here, nearby, just went up 55% because of the balance between, government and the like. So again, it's all about balance. In nature, things on homeostasis, in the principle of business and in our communities, they work best that way too. And then leveling the incentive. So the small, medium enterprises get the SMEs, and that's once again balance. Our strategic initiatives are critical, and that is obviously we're a growth-minded. We have a growth-minded agenda. That is not only do we focus on the businesses that are here today and make them grow and thrive, but you also bring in new businesses. It's our workforce. Every single business owner has a strength, not as a weakness. Okay. That means that we also hold elected officials accountable. Work permits for long-term migrants, which impacted my heritage, Mexican-American community, a lot, and many other communities. President Biden told us that he was going to pass. And I think we've teased the American dream to a lot of groups, i.e. the dreamers, and told them it's nice. We're going to let you go so far, because we're not going to give you the ability to work in the field in which you are educated, because we don't go the rest of the states in our American population. It's a failure of both political parties. I'm not just saying it's not the party in power. I think that this last election was a wake-up call for a lot of people to see exactly, hey, we're not going to just give our votes unwillingly. The takeaway from that is be politically agile. Vote with your pocketbooks. Vote with your housing. There's a book that I'm reading right now, and if you haven't picked it up yet, I would recommend that you kind of dip into it. It's a book called Abundance by Ezra Klein. And Ezra Klein's a reference for Ezra Klein because being a business guy, they're like, all right, so Ezra Klein's politics are probably a little different from a business person. What I like is both sides as being contributors in the 4 key issues that he talks about. Housing, and green energy, okay? And he says, yeah, both sides, when they've gotten into power, they've done more back and put them move us forward. And let's just take it. He takes the one issue of housing, because this is one that's on Chicago and New York, and you look at the cost of living, the amount of unhoused, and the impact of those areas. That's what Ezra Klein says. He says, if you're saying that what you don't like in Washington right now is we should follow the model of your city, then you need to kind of look at how you're leading in cities, because it's not working. You have the highest amount of cost of living, you have the highest amount of homelessness, and you don't have a solution. You're creating bureaucratical messes that prevent you from building. We have that problem here in Chicago. The small number of in the skies today means there's 1, no investment, 2, no impact, and no jobs. Okay? And we do more to try to complicate through zoning and pearl clutching, because nobody wants affordable housing in next to them. They don't want multi-units, because that creates a problem for everybody. Now, next is on the list is energy. Really making sure that if there's going to be an energy omnibus, it includes all voices at the table. It includes business. It includes our friends, and we're going to see that taste of that this summer. Those of us that pay ComEd and those of us that pay AM. And going back to my economic balancing statement, you're going to be born by the market. Okay, those of you that live in a condominium, you spend other people's money. That's basically what's happening. To increase the value of businesses that are here today and to be attracted to the state. It's the triangle of trust. So 90% of politics is local, so it's important for businesses to be involved in their local chambers, okay? Secondly, if there's an industry association such as this one, okay, it's important for you to be part of that. And, say chamber, excuse me, because it's important for all three of us. We all defend the interests of business, writ large, up and down the state, and make sure that business is seen. As a former business and current small business owner, I know that I'm so busy, you're so busy doing, making the donuts and doing what you do on a daily basis, that you don't have time to get into policy issues, but you want to be able to be informed at a quick glance of what are the critical issues impacting your business sector. All right? So that's the importance of this triangle of trust. One of bridge building. It's less of scarcity, it's less of the guy out, it's more of how do we build bridges together. And that's the way it's the largest in the state with regards to our expertise, our subject matter experts. Environmental. It is pretty much every infrastructure. You'll see every major sector represented here that impacts business today. And that's what you get as part of your chamber membership. It's a little different from this is why we protect the interests of the state. And our approach is one of growth. You learn as a business owner that you have to take care of your core business, what's known as core business first, and go out and get new business, because it's harder to bring in new customers when you don't keep the current ones happy and they leave or they get courted by somebody else. So our approach is one of growth. Focus on that core business and go out and get new business. And there's an op-ed piece that we wrote recently about a growth strategy for Illinois that was in Cranes. And really, versus the redistribution, give it to another, that just means somebody's losing out. When you grow and you take care of your existing core business and you go out and get that and you make sure that it is adequately appropriated, then everybody grows, not just one side. Okay? So as we sit in the major topics that we're looking at here, this session is really, as mass transit reform is very important to the northern half of the state, actually to the state writ large. Any energy storage and reliability is one of the issues that as we close the session out this week. There's also a procurement omnibus that we're looking at from a healthcare side of things. And our state's looking at a $3.2 billion deficit, so we're trying to manage that. That does not fall back on businesses and taxpayers. Okay? And lastly, I like to say that everybody asks me when I go for media interviews, what are you afraid of Washington doing? And I'm like, I'm not so afraid of Washington because 90% of politics is local. But what I am afraid of us doing is doing to ourselves. We have a pretty darn good job. We do a pretty darn good job of getting in our own way sometimes. It's well intended, but it's because we don't often circulate the opinion from enough people. And when I look at the federal tea leaves, I'm always asked that question, and I say, well, I'm more worried about what Illinois is going to do to itself. Are we going to continue to expand our spending at the state level to the point where it now requires more people to be taxed, or more services that you use, which is one of the things that's on the table right now? So when you go to the dry cleaner, or you go to the nail salon, or you go to get a service, you take your dog to get a bath, or get its nails groomed, are you going to now pay for those services? It's a tax. The guy on the fifth floor in Chicago has said, oh, there's no property taxes in Chicago, but he sure did raise your iCloud. He sure. My kids remind me of that all the time. All your subscriptions. So it's inflation. It's a circular inflation. And it's coming at the point where it's really navigate the current tariffs that are being held. I've been involved single-handedly in a lot of that with Costco getting that 90-day pause. And now we're just going to turn into and then just making sure that states don't get into things that they can't get out of. And by that, what I mean is legislation that creates a patchwork of legislation throughout the state in the area. And by that, I mean, for example, we're going to pass this legislation called CARB, which was well intended that the transportation industry specifically will be an issue that you can't legislate at state to state level, because if Nevada's not on board, then it doesn't matter what California wants to do that way. And that's often what happens when you end up with a patchwork of legislation. federal government is not leading, everybody does their own thing. And the Sandoval House, I have said, when everybody cuts for their own laundry, that's a problem, because the chamber is really, it's less about partisanship for us, it's more about our legislative against something. It's great, it's okay to be against something, but what are you for? And that's actually so. Thank you all for your time today.
Thank you, Lou. Thank you. Business side for that one, Pastor Lou. Because it's an international conference and the Illinois government is giving and all that. So it's given from the business side that will encourage the people to come and
Next, we're going to ask Commissioner Wallace.
And I also want to take a moment to thank former Commissioner Frank Avila for acknowledgement that we should rebrand that as cost savings in this moment, and resilience. Who knew that sustainability and resilience should be cost savings, but that's where we're going to get progress. So, we are planning for a sustainable future. Brief overview. I'm going to cover the air quality, dissolved oxygen, ammonia, and phosphorus, and cover within our service area, and also protect the water. So there was a bold plan in 18, what it looked like before the reversal, and then a series of canals were put in 22, and this collectively, along with the River and the Plains River, we talk about as the main control structure. That's the locks that folks have to go through into Lake Michigan. This is kind of one of my favorite pictures too. So yeah, this is where the big tourist boats have to come through, and the water comes up and down based on, and also I think Baha'i too, when we have these rainstorms, and so the challenge there is the river has to rise to a level that's higher than the lake, and that sometimes is a very free. We've got some additional slides that Dr. O'Connor's going to cover that we remember Cicero flooded, and it was also in 2020 that it became so precarious in order to let the river pass and then slam locks shut before the backwash from the river would come back in, and they had to just keep on doing this. So we're already straining our infrastructure. We're controlling lock systems, and there are still some that the city of Chicago would not necessarily like us to know about it, like Michigan. So here is the intercepting sewers. So this is a little small from and I can tell you when all these came. So these were exciting times. So starting here at Calumet, this came online in 22, and then in 23, the North Side Water Reclamation Plant, and then in 30, Stickney. This is, I think, the biggest world. Is that right? Yes. So this is, we have economies of scale. And then in 17, who is actually passed the Clean Water Act. Yep. Yeah. So we're looking for a lot of things, but we don't actually came to the Hanover plant. And these Northside plants are very interesting because, so this picture is to just show you what reverse and open the lake looks like. And then this is further approach shore, and then this typically, this plume that you see, will migrate down towards the Chicago beaches. So, and then you have the swim advisories, and the beaches are closed for the day. So with that, I would like to invite Dr. O'Connor to come, and for her participation, I'm going to deputize Dr. O'Connor with the UN Sustainable Development Pin, if she will allow.
So now I'm going to jump in. The plans have been built, the river's been reversed, the plans have been. Take a brief look at how these plants are have performed historically. So the three key parameters that I'd like to talk about before I bring up phosphorus is the five catch-all parameter that suggests how much and we measure dissolved oxygen in the waterways. So here we have, I'm sure why that doesn't show up. And in 1980, that was on the order of 20 milligrams per liter. I know my colleagues here from the plant are shocked that we got to 2025. It looks like we're tending around 5 milligrams. Is the limit of what we can analyze. So as far as we take that as far as we can. And now I'm here again as ammonia, and I apologize. The blue is the Calumet water reclamation and the effluent going into the CalSag, and O'Brien per liter in the effluent. And here we are, 2024, mostly non-detect. We really do fully nitrify. There's no ammonia making an oxygen. And now I just want to show, I don't know what happened with the, here, and we don't have zero DO in the CalSag. The river really has dilation, so at that time, 1980, we're discharging very high DOD, very high ammonia, and the health of the waterway was to literally put diffuser plates on the bottom of the and here are the SEPA stations. They were placed in service in 1994, I believe. Panaka can correct me. There's 5 side stream elevated pool aeration. At the time in the mid-90s, the projection cost estimate to upgrade the Calumet plant was on the order of $300 million. Dissolved oxygen to better nitrify. And the SEPA stations cost $80 million. And they were able to go there and take wedding photos. They are beautiful, and they do need water. Now, can I just take a minute? International group, I'd like to talk about this slide. The dark straight line is the world exceeding $8 billion, and we're talking about solid waste and water reuse. I mean, we really, but the point of this slide is, blue is phosphorus rock. My energy intensive, and that phosphorus is transported long distances. But as the world's population grows, so did our demand for phosphorus. Phosphorus is the current things, and it's an essential fertilizer. So the use of the fertilizer, phosphate fertilizer, I talked about BOD, biochemical oxygen demand, ammonia, and dissolved oxygen in the we were looking at phosphorus limits. So here's the schematic. We were able to work together, people in this formation plant. The primary effluent is the PE. The mixing channel is where primary effluent, the oxygen off the nitrate. So when that's fully denitrified, plant, there's 4 aeration batteries, and the 4 aeration batteries have 8 4-pass aeration anaerobic zone, the bugs starve of phosphorus, and we're pretty reliable at 0.2 or 0.3 milligram per liter phosphorus. Photos. Here's the anaerobic zone and the aerobic zone, and the phosphorus is taken up, and we've saved the taste of phosphorus out of our citrate. So here is the taste of phosphorus out of our citrate. So here is fertilizer. It is duplicates in the second class. We're good neighbors. Here's a picture of the aides in the second class. We're good neighbors. Here's a picture of the bioreactor. We put the off gas from our treatment. We believe we've taken our plans as far as we. Now, how do we manage stormwater? The board passed the Tunnel and Reservoir Plan in 1972, and concurrently, Stormwater Authority in 2004. We clear streams of 420,000 cubic yards of waste that would otherwise be your protection. Any new development, and most development, so it is mostly redevelopment. We have the partnerships I mentioned earlier, and now our perspective is the volumetric approach. We could go into Cicero, 1,000 acre feet of storage. Where are we going to put this? Underground. So here is a project that we 100% funded in Robbins, Illinois. We create residents out of the regulatory floodplain. We hope to go out this summer for the construction of the Central Park Stormwater Detention Basin. It's an underserved community, and they're calling it Central Park. They're quite thrilled. So the overall 18,000 structures protected, and here's the dollar values: $547 million spent on WRD total project cost. So I just want to talk, because I mentioned it before. Here is, I think we call it a heat map, a recap of the western suburbs, Cicero, and the 37th. Devastating floods, 9 inches of rain in less than 12 hours. Our tunnels were not full when we had pictures. And when we meet with the city, which we do meet regularly, there was a presentation yesterday on the storage, Lemoyne, and so finding all sorts of local collection, local storage, that we make the investment in pelletizing all of our biosolids for a smaller footprint. I'm very excited about, and I believe that we have activated sludge. That allows the activated sludge process to work at much lower traffic, and it's expensive. The biological process allows us to save energy. It's much. We need to arm our basements. Right, Commissioner? We both agree. 100,000 years ago, there was the same amount of water on the planet as today. So I don't know. Thank you very much.
Well, Denise was one of those people that just believed in me. It's hard to take this message out to the general public. So to try to say reuse is actually what I've learned is that you can't really talk. You can't say that word to either our regulators or the general public, but you can start with other words, such as return. We are returning the water to Lake Michigan, and that is language from the Great Lakes Compact. So not one single regulator should blanch at that word. But then there's also words that are being used in other sides of the country, such as source augmentation. And you can augment your groundwater, and you can augment your surface water, and what all those wastewater treatment plants and other amphibious discharges are doing all around Lake Michigan and the Great Lakes shores. They are returning water to the Great Lakes. They are augmenting our source water. So it's our already being done. We just need to recognize that that's what it is, and it is part of the natural water cycle. There's no new water on our planet. So I just wanted to let you know other examples of reuse that's being conducted. So the poster child for industrial reuse is West Basin, California, where they have 5 different water qualities fit for purpose, for purposes including irrigation, cooling water, groundwater recharge, including their saltwater intrusion barrier, and 2 different qualities for boiler feeds. For irrigation, as I mentioned, MWRD does park irrigation for both the Egan and Curie plants and more extensive irrigation system. And the reason that they did that is because it is literally cheaper than adding advanced treatment to take out the phosphorus. And the benefit is they had to get a specific variance from IEPA because of that 200-foot setback based on history instead of quality. So IEPA took a chance on a first-name basis with Getty Illman, who wrote that permit. I think that she is part of the future that we want to see, so I have to publicly thank her everywhere. Because of her, Village of Pingree Grove was able to install their system based on a permit of exception, and it irrigates the median between either way of the roads on, in between the roads, and then also the parkway that borders the residential property. And Pat Doherty, he was here, he's the Public Utilities Director, he would say that every night, he will tell you the story, every night the residents during the growing season, some of them will sneak out and turn those spigots to their property because they want green grass too, and in the morning his staff has to come and turn the spigots back to the right of way and explain how that's illegal in the state of Illinois. So that we would like to change that. I mentioned the Delano Sugar redevelopment, so 0.4 MGD from 5 buildings on 11 acres, return on investment of 14 years. This is the business practices that we need to change our local incentives to. We need to incentivize the work we want to see. This also provides, it reduces potable use demand of 200,000 gallons per day. It provides drought-resistant water supply for those buildings for non-potable purposes. It reduces flow to stormwater sewers and wastewater facilities, and thus the incidence of combined sewer overflows. So for potable reuse, right? This is heresy to talk about potable reuse in the Great Lakes Basin, especially Chicago. But I would like to point out that for those of you that travel to San Diego, do stop by the Pure Water Visitors Information Center. This is a key component of their public education program that they are going to provide anywhere from somewhere less than half to up to more than 1/3 of the city's water supply by 2035. In El Paso, Texas, this year was brought online the largest direct potable reuse system in the United States of America at 10 MGD. So that is wastewater going to advanced treatment, going to a permitted drinking water treatment facility with no environmental buffer such as a lake or river in between. Then also, and my favorite is Windhoek in Namibia, in Africa, has been doing reuse water since 1968, which is the year of my birth. So we share this birthday, and that reuse system cannot fail because all that water is required for basic sanitation and fire flow. So with that, I hope that this has inspired you to think about where we should be, envision the world as it should be if we could start all over, and then think about where we are now. Take one step forward to that future that we would like to see. Thank you all.
Thank you, Councilor Dr. Lal. I request Dr. Lal and then Dr. Ogana to just come onto the stage for a minute. On behalf of WWM International, we just present a memento. Now we are starting the next program. One of the important programs. First time, as a when we are doing this 7th international conference, we started this. We will be having that international awards of excellence in resource recovery. We will be announcing 6 awardees. Actually yesterday dinner night, day before, we announced only the awardees. Now I request Commissioner Dr. Waller to come on the stage and help us in awarding the mementos. Before that, going to the awardees, I have to recognize one more thing. You see in this type of conference, international conference, we did it with $0 administrative costs. Right? But how? We see only 3 people here, but we are not only 3. A ton of volunteers workers we have as we got a minor deal. Arpita, Ravi, and a bunch of other people. Don't forget that. No, okay. Okay, I'm not telling you. So, we use them they are given their best to us. And we have seen that how the international conference has been run in Chicago with this $0 cost. Hope everybody will appreciate that. And one more round of applause to all the people. This is motivate them down the road. At some point, like they will come here and take the Resource Recovery Excellence Awards on the stage. Now, let us go to the first awardee. Yeah. Oh, yeah. Okay. The first award goes to Dr. Prakash Tata. So, Dr. Tata, he has more than 60 years of experience in the field of water and wastewater treatment, and he served as a assistant director of the MWRD 22 years back, and then now working for the one of his own non-profit organization, and he is also the executive director of the Center for Transformation of Waste Technology in Naperville. And I request Dr. Tata, because if I go on telling his achievements, then probably we will end up the day after tomorrow here. So, Dr. Tata, please come on the stage to receive the award.
Let's come in the middle. Done a lot of research, and like you can see that the University Vice Chancellor mentioned here, $40 million of the inflow of the money into his projects here. So I request middle. That's okay.
Okay. The next awardee is Professor Krishna Reddy. He is a USC professor and and Distribution Register, and from the Department of Civil, Materials and Environmental Engineering, and the Director of the Sustainable Engineering Research and Geotechnical and Geo-Environmental Engineering laboratories at the University of Illinois at Chicago, and he has like the labs, and we did that one too, on that how the solid waste can be effectively remediated, and then using the landfills and all that. A lot of PhD students working under him. Thank you, Dr. Reddy. The next awardee is Ruth Abbey. She is the president of the Zero Waste Association also. Ruth Abbey. The next award is Dr. Uday Kelkar. He is the founder and the CEO and managing director at the NJS Engineers India. You might have seen his knowledge and other things during the panel discussion. He was an American citizen, he went back to India, and he is now running the NJS Engineers, and in the water and wastewater, he is doing a lot of projects. So thank you, Dr. Kelkar ji, for all you are doing like that one. So the next award goes. The next award goes to Dr. Abdul Salam Muhammad. He is the CEO of the Marcus Knowledge City. And you have seen his knowledge, like what we have got like last 2-3 days we have shared. He is an ISRO scientist. And then he returned back to India and doing that. He was like one of the model one. Now also yesterday we started a program. We started with 3 projects, 2 from India and 1 from Thailand, and he is like the project coordinator for one of the village that we're doing. Thank you, Dr. Abdul Salam ji. Now we see that how the power of the Chicago. We did 6 conferences international, came back to Chicago because we were at our home, we made a home run, right? So with all the people like you supporting with us, now hopefully in the next conference we remove the wall, make it 400, and then we have got this next floor also, and with the great support of all of you, spread the word, and then we'll be making the more greener societies everywhere, all over the world. Thank you very much.
first coming to the conclusion session, so Dr. Tata has a few words. Dr. Tata is anyway our founder, and because of his inspiration, the WWM has come up all this day. So I request Dr. Tata to say a few words before the word of thanks from our secretary, Chairman Dr. Tata.
Vote of thanks will follow, I'm sure. And you know, this is a thankless job. I know at least 3 people, along with associates, are working like crazy. I know how Sam is. I worked with him for 6 years. I need a break this time, I said. So I want to honor the 3 volunteers. Sam Popo, please come here. The president of the coming. I call them, I have a small entity which is called Bharati Tirtha, established about 120 years ago in the town of my birth. And I rejuvenated it in 2003. In 2006 as a 501c3 organization. Ever since I've this organization along with these guys. And so I call them, it's a medal. You see? On one side is the logo of Bharati Tirtha, that means goddess of education, the abode of the goddess of education. And on this side is the water warrior. You guys are warriors. Partners in crime. So, I'm happy with you. Mr. Water Warrior from now on. He doesn't listen to me anymore. Sam gave the task of conducting a panel discussion about and there are some great people in this panel. They walk the talk. We talk. So many PowerPoint presentations. How many of you are going to walk the talk? Do something in your life. Paying from your pocket, not paid by somebody else. And there are some people I know about that. So they were in the panel discussion. I'm going to also call them water warriors. Dr. Chitturi Ratnam, please come here. This young man, he did his PhD and all the stuff. Get up. I don't know how long, but more than 30 years, this gentleman is doing a great service, bringing up the kids, walking up sustainable development and all that. And I call you, sir, from today on, you can call yourself a water warrior. Water warrior. Water warrior, yes. He really walked the talk. 35,000 children got scholarships from his foundation, the Artsel Foundation. And he's still continuing for the development of rural areas in India and elsewhere. Thank you, sir. God bless you. Next one. Srinivas, where are you? Liam, Sunil Rajavarman. I call him. Srinivas is more than Sunil, you know. And this gentleman, I came to know about him only 12 days ago. This gentleman works in Calgary for a great organization, CAST, C-A-W-S-T, Center for Affordable Technologies for Sanitation and Water.
Center for Affordable Water and Sanitation Technology.
And it's interesting, you know, I was introduced to him, to another friend in India. I attended the webinar, and he is another partner in crime. He has been working in villages in various countries of the world, and he happens to be an Indian guy, working in Canada, for God's sake. And I requested him to come here and look at him, and he has some money with his director. We don't have any money to pay for these guys. Still he came here with the passion that he's working. And he said, sir, you're really a water warrior. Here it is for you. And there is a young lady, where is she? Shilpa. Where? Shilpa was here. No, she's not here. Srinivas Atluri. This young man has come all the way from India. Bike how many kilometers? How many? 30,000 kilometers he bike. Abdul. Come on, sir. This is another man ever smiling from Kerala, the beautiful state in India. And again, smart city. You're a smart city of 1 year now, right?
Dr. Saida, please go on.
I'm sitting with her and having lunch. And I discovered her father also came to the United States in 1962, right? 66. On behalf of this International Association, which is our water warrior. Thank you, Father. Thank you, Chief.
Thank you, Father. Now, Captain, please propose the word.
Good afternoon, everyone. First and foremost, thank you all for staying and being so patient. We really appreciate that. It's been an exciting, it's a great honor and privilege to deliver the vote of thanks. On behalf of the organizing committee, I extend our heartfelt panelists and experts who have shared their invaluable insights, experiences, keynote speakers, for setting the tone so powerfully and for challenging us to rethink responsible and successful. To our moderators and session chairs, thank you for ensuring the smooth flow of discussions and for facilitating such engaging and productive exchanges. To all the participants, researchers, students, policymakers, industry leaders, and practitioners, thank you for your active engagement, thoughtful questions, and collaborative spirit. Your presence has made this conference a vibrant and meaningful platform for learning and great connections. Behind the scenes, a sincere thank you to our organizing team and volunteers. Each one of you have made a big effort and with this and dedication to all details. Finally, let this not be the end, but a new beginning. May the discussions and connections forged here today translate into continued collaboration, innovation, and impact in the fields of water management, waste minimization, and resource recovery. Thank you once again, and we wish everyone a safe journey and continued success in your endeavors.
One more small announcement. Who are residing in Chicago area, this small here, this program is going to be organized in collaboration with the International Association of Water and Waste Management and also the Rotary Club of Naperville. Rotary is doing a lot of work around the world. Anything I do, the celebrations, I do in conjunction, collaboration, even telling them or without telling them. It is a collaborative effort that I give them. Besides learning a lot of things from the Water Reclamation District for 30 years, commissioner, both the commissioners here. So, a debt of gratitude to all these people. So I invite you, if you are in the afternoon at 2 o'clock at the Naperville 95th Street Public. It's a great forum. And he was telling this is the beginning, you said, so. Yes. So that's already begun. Thank you very much.
Thank you. We welcome all the feedback, positive feedback, negative feedback, because this is our first conference, so everything what we are going to get back from you, the feedback, will help us improve for our next year's conference, which I don't know it will be. But definitely we look forward to having the next conference in Chicago in Boston. Thank you.
పంపించాం కదా